So on 4.5, you need to make sure that you have your graphing calculator. So we have added, we have subtracted, we've multiplied, and we have divided rational expressions. So now the only thing left to do is to graph them. So remember that a rational function is an equation that has a polynomial on the top in the numerator and a polynomial in the bottom. That's what this P of x, Q of x business is. Okay? Again, this just means that the numerator and the denominator are polynomials, so like x squared and yada, yada, yada. So when we are graphing rational functions, we are going to look for two things. The first thing that we are looking for when we graph rational functions, and we're going to rely heavily on our calculator, okay, is the point of discontinuity.
Big word.
Yeah, big word.
What does it mean?
The point of discontinuity. What do you think discontinuity means? What word do you see there?
Where it stops.
Where it stops. Discontinuous, right? Discontinuous means that it stops where it pauses. Okay, so what this is going to...
Where it stops.
Yes.
Good time.
This is going to leave us a hole in the graph. Yes. This is going to leave us a hole in the graph of what we're doing. Okay? We are going to look for the common factor. So the work we've been doing with simplifying, multiplying, and dividing, where we cancel things out, you know, the things that are in common, that's what we're going to look for to be able to find our point of discontinuity. We're going to take our common factor and we're going to set it equal to 0. I like to use PD as an abbreviation for this one. This is our PD, our point of discontinuity, instead of writing that word every time. The other thing that we're going to be looking for is called a vertical asymptote. This is a math word. Vertical asymptote.
Is there any somewhere for the vertical line test?
Not the vertical line test, but it is a vertical boundary It's a vertical boundary, and we find it by looking at whatever is left over in the denominator. So I like to say leftover. Only in the denominator. We don't care about the numerator. And we set it equal to 0. And I'll explain why in just a few minutes. We're going to call this our VA, or our vertical asymptote. You are going to need to know the difference between the two. Yes?
Is it completely important to know the nomenclature of math? Or, like, am I ever going to have to know and put down on a test that this is what an asymptote is?
Yes. On Unit 4 tests you will. And on your final exam. Okay, so if we think about this, you're going to need to know the difference between the two. Okay? So let's think about a point of discontinuity. A point is a hole, right? If you take it out or you open it up, it's a hole. So the point of discontinuity is the hole. And we'll talk about how we can remember which one is which as we do an example. So let's look at example number 1. It says, determine the equations of any vertical asymptotes and the values of x for any holes in the graph. That sounds kind of intimidating. Okay? It's not. Step number 1. What do you think step number 1 might be? Think about what we've been doing every single time we see a problem like this. Factor. Excellent, Austin. We are going to factor. So if you are a steps person, step number 1 is to factor the numerator and the denominator. just like we have been doing the whole time. X squared minus 1 factors to what? Okay, x plus 1, x minus 1, right? How do we factor that denominator, Tish? X factor it, okay? You go ahead and do that. X factor the denominator. -1, -5, I would agree. Okay, step number 2 is look for the PD. And remember the PD, the point of discontinuity, is the common factor. So what do these two have in common? Excellent. The x minus 1 is in common. So let's think about this. If I cancel the x minus 1 out, okay? If I cancel x minus 1 out, they both have it in common. I'm going to cancel it out. If I cancel something out, I leave a hole where I pulled it out of. So if I'm pulling x minus 1 out of this equation, out of this expression, I'm leaving a hole where it should be. That's why it is the point of discontinuity, because we're taking it out. So we're making a hole in our graph. So we're going to set this equal to 0. And I'll explain why in just a minute. So we get x to be what? 1. This is my point of discontinuity at x equals 1. What that means is if I were to put a 1, look up here for just a minute. If I were to put a 1 in for x in my denominator, watch what happens. You don't need to write this, I want you just to watch. If I put a 1 in for x in my denominator, I have 1 minus 6 plus 5. What is 1 minus 6? -5, and -5 plus 5 is what? 0. Can you ever have 0 in the denominator of a problem? No. That's why there is a hole in this graph, because I cannot have 0 in my denominator. Okay, and when x is 1, it gives me 0 in the denominator. That's why I have to look for it to say, hey, look out for x is 1. Okay, the third thing that we're going to do is look for a vertical asymptote. Now, not every graph will have a point of discontinuity. Not every graph will have a vertical asymptote. Okay, so the vertical asymptote is whatever is left over in the denominator. So what in this example is left over in the denominator? X minus 5. Excellent. So I'm going to take x minus 5 and I'm going to set it equal to 0. I add it over, so x is 5. This is my vertical asymptote. Excuse you. What that means is if I were to plug 5 in to my denominator, if I were to plug 5 in, that's 5 squared minus 6 times 5 plus 5. 25 minus 30 plus 5. What's 25 minus 30? What is -5 plus 5? 0 again. So when x is 5, I'm also getting 0 in the denominator. And does 0 work in the denominator? No. So this means I have a boundary line at x to be 5. All right, so when we put this in our calculator to graph it, the first thing before we use our calculator, the first thing I'd like you to do is draw your x and y axis. Okay, so make an x and a y axis over here. I'm going to scoot my y-axis over a little bit because I know I have a boundary at x is 5. So I'm going to draw a little off-center like this. I know that I have a boundary line when x is 5, so I'm going to go ahead and draw a boundary line, and a boundary line we're going to use a dotted line. Okay, we're going to label it. I know that this is my vertical asymptote, so it's a vertical line. And now we're going to use our calculator. When you use your calculator, it is very important, before you start using it, I want you to look up here for just a second. When you use your calculator, it's really important that you put this x squared minus 1 in parentheses, then divided by this whole thing on the bottom. We go back and we put the original in. Okay, so I'm going to use my graphing calculator. My drawing will come back in just a minute. Go to your y equals. I guess I have to turn it on first. Clear anything out that's there. And then in parentheses, I'm going to put x squared minus 1, close your parenthesis. If you don't do this step of opening and closing your parenthesis, you are going to get the problem wrong. The graph is going to give you the wrong thing. Divided by x squared minus 6x plus 5. Close parenthesis. Does anyone need help finding it? Where the x is or anything? Got it? You're just typing in the problem. X squared minus 1 in parentheses divided by x squared minus 6x plus 5 in parentheses. Okay? And then we're going to hit graph.
Oh, one of those. Oh, God.
Do you guys have this on your graph? Okay, check with your neighbor if you are having trouble seeing my graph on the board. See if you guys have the same thing. Okay, go back to your y equals and see if you missed a parentheses. Do you notice? Look up here on my calculator. Do you notice at 5 the graph splits? You guys see that? When x is 5, the graph splits, right? Because there's an imaginary boundary at 5, meaning your graph is never going to touch 5. It's going to get close to it, but it's never going to touch it. Anthony?
What are you trying to like realign?
You're going to go to Zoom.
I don't need it.
Number 6. If you need to readjust your window, go to Zoom and number 6. Go ahead and sketch that. Go ahead and sketch that on your x-axis. Okay, just because this is whacked out. So that's why I know it's not going to do it. Yeah. You have too much on yours. Oh, okay. Yeah, yours is just. Is there a half? Yeah. Okay, sketch it on your paper. Yeah, but you have 5x and it's 6x. You forgot this was 6x plus 5. Okay, so sketch this on your graph. Anybody else having trouble finding theirs on the graph? Okay. Now, I'd like you to do something. I'd like you to go back to your graph. And I want you to go to second table, which is right above the graph. Second table. Second. And then table, which is on the graph button. Now, do you notice at x is 5 it says error? So you might have to arrow up and down to get your x values. Okay, where did mine go? Okay, do you guys see that when x is 1 there's an error?
Yeah.
And when x is 5 there's an error? Isn't that interesting that we said the point of discontinuity is at x equals 1. Did you arrow up and down to find x is 1? Find where you have x to be 1. Do you have it? So keep going. Keep going. There you go. When x is 1, you have an error. That's because there is an error there, which means the graph does not exist when x is 1. And likewise, the graph does not exist when x is 5. So we already knew those things, but this table verifies that. All right, so if we are on our graph that we are working on over here, and you drew it like this and like this, it says we already knew that we had a point of discontinuity at 1. So when x is 1, okay, when x is 1, right here on my x-axis, I need to erase this and put a hole right here. Does everyone see what I just did? When x is 1, I'm going to erase that part of the line and put a hole there, because that's where I have a point of discontinuity. So I erase that point, and I'm going to draw a hole in my graph, because you have a point of discontinuity there when x is 1.
You do the same thing on 5?
Nope, because on 5 there's not a point, it's a vertical asymptote, right? It's different.
You're talking about the imaginary line or whatever?
Right, the imaginary line, that's called my vertical asymptote. Not a hole, it's a vertical asymptote.
You only want to look at this part.
What?
Do we erase the horizontal part or no?
What horizontal? No, you can leave it like that.
Okay.
Okay, there at the bottom then it says, look at the bottom where it says your point of discontinuity. Point of discontinuity is at x equals 1. If you just tell me 1, it's wrong. It needs to be x equals 1. Because if you just say 1, are you talking about the x values or are you talking about the y values? And we also have a vertical asymptote at x equals 5. Now again, not every graph will have a vertical asymptote and a point of discontinuity. They might have one of each instead of both of them, one or the other. Okay, let's look at example 2. Step number 1 is to factor. So we're going to factor the numerator and the denominator. What does x squared minus 9 factor to?
X minus 3, x plus 3.
Excellent. X minus 3, x plus 3. All right, say that a little louder, Brianna. The bottom is already factored. There's nothing else we can do there. Step number 2 is to find the PD, which is the common factor. Is there a common factor here? The x plus 3, and we cancel it out, but we have to set it equal to 0, remember? So I have a point of discontinuity at x equals negative 3. That means I have a hole in my graph when x is negative 3. I can go ahead and put that down here. So then the vertical asymptote is what's left over. Do we have anything left over in the denominator?
No.
No, we don't. So is there a vertical asymptote here?
No.
So we're going to put in A, or you can put, this is called the empty set. So on the vertical asymptote blank, you need to tell me that it doesn't exist. If you leave it blank, I don't know if you accidentally left it blank or you didn't know if there was one or not, so you need to tell me specifically that there is not one. Okay, now we've figured that part out. We're going to use our calculator, our graphing calculator. Remember to put the original equation, x squared minus 9, divided by x plus 3, in parentheses, both of them. Bless you.
You divide it, right?
Yep, the fraction bar means division. Okay, some of you are just getting a line. Is that right?
Yes.
So x squared minus 9.
Not 99.
Yeah, that would be crazy. Divided by x plus 3. What?
I didn't know delete, like erase one of them.
Yes, delete, erase is only one of them. Do I have an x plus 3 on the bottom? I can't remember. Yeah? Okay, does anybody know why we just have a line here?
Because it only goes to the -3.
X minus 3 will be because it doesn't have a vertical line.
Okay, do you guys see over here the only thing that you had left? The only thing that you had left was x minus 3 in the top, right? After we canceled those things out. And x minus 3 is a y equals mx equals b, right? So I went down 3. This is my b value. This is my m. Do you guys remember that? So that's why our graph is only a line. So when I graph this on my graph, so I have my x-axis and my y-axis, down 3, I don't have a vertical asymptote, but we did have a point of discontinuity, right? And our point of discontinuity was
-3.
x equals -3. So on my x-axis, x is -3 is here. And so I'm going to travel down to where my graph actually hits that. And draw a hole there. So I have a point of discontinuity at x equals -3. So -3 is back here at this point. But my graph doesn't hit up here, right? My graph hits down here. So that's why I have to go down there and draw my point of discontinuity here. Questions on example 2? Okay, example 3. Why don't you see what you can do on your own on example 3? I'm going to pause the video and I want you guys to go ahead and start example 3. And we'll see if we get the same thing. Okay, so when we get finished factoring, I should have 2x minus 5 over times x plus 2 all over 2x minus 5. Do I have a point of discontinuity, Brianna? Point of discontinuity, remember, is what they have in common, right? So they have a 2x minus 5 in common. So my point of discontinuity, I'm going to get by doing 2x minus 5 equal to 0. If I solve that for x, I get 5 over 2. What is 5 over 2 as a decimal? Because I'm supposed to graph this.
2.5.
2.5. Anybody agree? So my point of discontinuity is at x equals 2.5. Is there a vertical asymptote in this one?
No.
You don't have anything left over in the denominator, right? There's nothing left in the denominator, so you're going to tell me that it does not exist by drawing the empty set there on your vertical asymptote. Yes, Brianna? You do not do anything with the x plus 2. Because the x value in the numerator can be anything. It's just in the denominator that we're going to get 0. Okay, so now you're going to use your calculator. Bless you. Please make sure that you put the whole thing in parentheses because, again, you're going to get the wrong answer if you don't put it in parentheses.
Can you explain actually what you put? Because I went to do this on my own and I couldn't look at what specifically.
Okay, can you see my thing up there? So whatever is in the numerator, that 2x squared minus x minus 10, do you see that in the numerator of your problem? You're going to put that entire thing in parentheses. Then divide, and then another set of parentheses, whatever your denominator is. Okay, we have another line because remember we were left with x plus 2. So when I graph this, this is what my graph should look like. I have a hole at 2.5, so 2.5 is approximately right here. But my graph doesn't touch that actual point, so I'm going to go up to where my graph does touch that. Erase. Put a hole in the graph. Does anyone have any questions?
When will we use this in real life?
You probably won't ever use this in real life, but what you will use is the critical thinking skills that I'm teaching you.
I'm just curious. If I had a dime for every time I heard that, I would not need to go to class.